Hey there, grade eights. Topic 2.1, waves and tides. This is page 349 to 354 in your textbook. I'm going to go over the slideshow fairly quickly because there's going to be a few YouTube videos that you're going to be using and possibly a demonstration that I might record and ask you guys a few questions. Maybe I'll give you a quiz question or something. So let's go. Uh, so first off, how does water move? Water moves two ways. Well, three ways actually. But the two ways we're going to talk about here are tides and waves. These are two examples. The other way is currents. Water moves in currents as well. We'll be talking about currents a little bit later. And here's a beautiful picture that's out of your textbook. If you take a look at it, you see a nice little seagull way up here, and we've got sort of a rocky edge with a whole bunch of different colors. At this point, I'd be asking you, why is this? Okay, and the reason is it's tides. Okay, so as water tides, as you guys know, tides, the water moves in and the water level rises. The water gets up to about here and then it goes down. And based on that, we get these different colorations. Okay, coloration down here, the water, this area of the rock is covered by water more during the day than up here. So we end up getting a lot of barnacles and things like that living on here. Up here, we have water's not touching there that as long. So we get some salt deposits. The water hits it, then it starts to go down, the sun evaporates the water and leaves the salt behind. There is also, if you take a look up here, it's all nice and smooth, whereas down here it's kind of rough. Another reason it's nice and smooth here is the tide coming up and down, eroding away at the surface, as well as waves hitting the shore or hitting the surface, eroding away slowly. So both of those are great examples of tides and waves shaping the shoreline. So first off, we'll talk about waves. Waves are a changing motion on the surface of the water. Waves actually don't happen deep in the water. And there's a really cool video that I'll be sharing where it actually shows the waves on the surface, and down below it has some nice little fishies just swimming around. It's really cool. I'd stop it and pause it during in the class, but I won't be able to do that. So watch for that. You'll see waves on the surface, and down below you'll see the fish. The waves are only on the surface of the water. Uh, so the water itself with waves actually does not move very far. It's just typically moving in small little circles. Think of taking a skipping rope or a rope and flicking it up and down. The rope itself doesn't move. Well, the rope moves up and down in a wavy motion, but this side of the rope, the rope on this side, does not move over to the side. It's just the motion of the wave. So water within the waves just move in tiny circular motions. This is very important. There's going to be a lot of quiz questions about this. So remember, just tiny little circular motions. And here's a beautiful picture. Okay, so we have the wave in water, which you can sort of notice. You would see this on a lake or something along those lines. And it's just on the surface here where that wave is moving. So these water particles are just moving in a small circular motion. They're not moving down here. The nice little fishies would be able to move down there. Most waves are caused by wind. The stronger the wind, obviously, the bigger the wave. So effects of the shoreline. We already talked about that. I showed you the picture, that first picture. In deep open water, again, like I said before, the waves appear as up and down water movements. Okay, an object that's floating in the wave simply just bobs up and down. So at this point, I go and I take one student and I say, okay, you're just a little kid playing on a beach, and then I choose another student, and that student's a big bully and goes and picks that kid's bucket and throws it into the water, and the kid's crying, oh, boo hoo hoo, right? So how can that kid go and get his bucket? The little boy doesn't know how to swim. So I'll have another kid, the big brave hero. They come by and say, "Don't worry, little kid, I'm going to come and help you." And some of them say, "Well, we'll throw rocks onto the other side of the pail and cause waves or ripples to carry the bucket back." Okay. And at that point, we discuss, well, that's not going to work because it's a nice, calm day. There's no wind or anything like that. And the waves itself, or the ripples that the rock create, are just circular motions. So all the bucket will do is bob up and down, up and down. What they would have to do is have some sort of wind come by and create waves in the water, but the wind would also end up by pushing the bucket and cause that bucket to move. So if it was a nice, calm day, and a bucket was floating in the middle of the water, and you were to create some waves or ripples, or if a boat was to come by and create some waves or ripples, that bucket would just float up and down, bob up and down, and because the waves themselves are just small circular motions. I hope that makes sense. However, in shallower water near the shoreline, so as the waves or the circular motion in the deeper water moves along from deeper to shallower, eventually it gets to areas that's so low that the ground is in the way. So the circular motion comes in contact with the ground. And at that point, when that circular motion comes in contact with the ground, so we got circular motion. Now the circular motion is hitting the ground, it starts disrupted. The ground disrupts the wave a little bit, okay, and the wave itself disrupts the ground, so it causes the ground to move. Maybe little rocks and sand and whatnot move around, and also with that turning, that's where you get the crests or the wave breaking up. So you see those little white tips or the white cresting of the wave. You see that on small waves, it happens close to shore. On larger waves, depending how big that circular motion is, it happens a little bit deeper. So think about being out at the beach and somebody rips by on a boat. You may see the waves coming in, they come in, and you just see the water moving up and down. And then eventually you see the water crashing over. So you see the white fizzy stuff or the white fuzz or foamy stuff, I should say. That's because the waves are so large, or the circular motion so large, that it's hitting the ground and breaking up. And that's how it affects the shoreline, because the closer it gets to the shore, the larger the waves, it starts moving that the the ground the ground underneath the water, the surface. So this can shape the shore, so the shape can change. Rocks and sand can be eroded away. Erosion is a very long process, which we'll be talking about tomorrow. I'll probably giving you a next day, I'll give you a Bill Nye video for that too. The wave can also deposit sand and other materials. So as it's turning, it's moving that sand and mineral and things that are material that are at the bottom of the water. And that's how that all gets deposited along the shoreline. And here's a couple pictures of waves affecting the surroundings. This first one right here, Pierce Rock, down in Quebec. You can see that there is a little hole, or a fairly large hole, in this big cliff, as well as along the sides. You can see the water has worn away, so the waves would move, and slowly they break away at the surroundings around this and creates that cavern. And then right here, you can see a lot along these shorelines. It's not as smooth, it's kind of rough. This shows um, waves depositing gravel and stuff along the shoreline. Think about beaches. If you go to Gull Lake or something like that, the big beach at Gull Lake, the beginning of the year, they may put nice sand down and whatnot. You go later on in the year, that sand, there's still sand there, but maybe it's not as nice. Maybe there's a little bit more pebbles and rocks and things like that, because it's all eroded, and it's eroded away or was deposited from the waves. At this point, I'll show a little video. This is the video that I'm going to be showing you guys. I'll put the link because unfortunately it won't play on the Loom video. So I'll make sure you guys watch this link. It's a very good one. Okay, and here we're going to start talking about the next thing. It's tides. Surprise. Oops. Okay, oh my goodness. It's not cooperating today. Okay, sorry about that. Okay, so we have two pictures. This is right out of your textbook. Okay, but we have two pictures. We got a yellow boat here, green boat here. Oh, green boat's gone. Blue boat here, blue boat here. It's essentially the exact same picture. Okay, at the same location and two different times during the day. This is the point. I'd ask, why is this? Then I hit click and you see tides down there. It is because of tides, high tides versus low tides. And we're going to talk about this quickly. So here's a beautiful picture of our Earth. Some of you probably remember this from grade 5, I want to say. Maybe it was grade 6. I can't remember. But we've got a beautiful picture of the Earth here. We've got a tide over here, high tide over here, low tide up here, low tide over here. And over here, we have the cause of all this. It is our moon. Okay, so tides are daily water level changes in the ocean. Okay, and they occur approximately, not always, but approximately every 6 hours. In some cases, it might be 8 hours, but they approximately occur. You get 2 of them a day, 2 high tides a day, 2 low tides a day, typically, and they're caused by, as I already stated, The moon's gravitational pull. You guys all know this. As soon as we come up here, there's somebody that says it's caused by the moon. You guys are experts on tides from previous years. Okay, high tide is when water is at the highest, and low tide is when it's at the lowest. So going back to that previous picture, when all the boats were just sitting on the shoreline, that was low tide. When all the boats are floating in the water, that was high tide. Okay, and there are two of each, approximately two of each every day, depending on the season and the way the Earth's rotated and exactly where. That doesn't always happen, but typically there are two a day. If there is a test question, the test question is going to be, it's based on the moon's gravitational pull. And as you can see right here, the moon is pulling the water this way. Because the moon is pulling the water this way, the water up here starts pushing down here, the water here starts pushing down here. But then we end up by getting a high tide also over here. Why does that happen? Why do we get a high tide on this side when all the water is pulling this way? Should the water not be going this way? That's an interesting question. I'm not going to tell you the answer because it is in the YouTube video that I'm going to share with you, and you might need it for your quiz. So I think I'm just going to put it on there to make sure that you guys watch that other video. And this is the dude that shows the video. It's actually a pretty funny one. Okay, the other thing I'm going to do is I'm going to do a making waves activity. I'm going to give it a try. If you guys see the video and see the questions on YouTube, watch it. I might not have the materials at home to do it. I usually use those big white buckets that we have at St. Martin's. So if we have it, great. If not, well, you guys will have to just use your imagination. All right, guys, that is it. I hope this made sense. I try to keep it painless because you're going to be watching some YouTube videos and then answering some questions. If you have any questions, like always, send me an email. I am just a click away. Have a good one.